Let's see some physical properties of hydrogen chloride. We had seen from the laboratory preparation of hydrogen chloride gas that it displaces the air. Since it is heavier than air, so it displaces air and we collect the gas by upward displacement of air. So it is denser than air. It is a colorless gas with a pungent choking smell. In most of the bottles of hydrogen chloride, you will see that it is written corrosive in nature. So hydrogen chloride is corrosive in nature. Now let's see the effect of HCl gas on a burning candle. So as we add HCl gas, you see that it extinguishes the flame of the candle. This means that HCl is not a supporter of combustion. So hydrogen chloride gas, is it a supporter of combustion? Is it true or false? So HCl gas is not a supporter of combustion. So the given statement is false. As we see, as we add HCl gas to a burning candle, it extinguishes the flame of the candle. So HCl is not a supporter of combustion. It's neither a supporter of combustion nor is it a combustible gas. That is, if we burn it in air, it does not catch fire. So HCl gas does not catch fire, so it's not combustible and it extinguishes the flame of a burning candle. That is, it is not a supporter of combustion. Also, one very important property of HCl gas is that it is highly soluble in water. This high solubility of HCl gas in water can be demonstrated by an experiment which is known as fountain experiment. Observe what happens in this experiment. So there is this blue litmus solution. This is a setup. See what happens. So you see a red fountain is formed. So let's see why this red fountain is formed. So this is the setup. In a trough, we take blue litmus solution. This flask contains HCl gas. HCl gas is acidic in nature. This is a rubber dropper containing water. Now, we press this rubber dropper. A few drops of water are squeezed out. As the water droplets enter the flask, since HCl gas is highly soluble in water, it gets dissolved in those drops. As it rapidly dissolves in water, it creates a partial vacuum in the flask. By partial vacuum, I mean that as the gas is rapidly dissolved in water, the pressure in the flask drops. As the pressure in the flask drops, the pressure here is high. So to equalize the pressure, this blue litmus solution rushes through this jet tube and enters the flask. Since HCl is acidic in nature, it turns blue litmus red. So we see a red fountain being formed. So this is the reason why this red fountain is formed. Let's revise how this red fountain gets formed. So first of all, we have to know that acid turns blue litmus solution red. So now what is happening is the dropper containing water is squeezed and some water droplets, they enter the flask. So as we squeeze the rubber dropper, some water enters the flask. Since HCl gas is highly soluble in water, it gets dissolved in this water. As soon as it is dissolved in this water, it creates a partial vacuum in the flask. By partial vacuum, we mean that since it rapidly dissolves in water, the pressure in the flask drops. Now the pressure in the flask is less. The pressure of the blue litmus solution in the trough is more. So now the blue litmus solution, in order to equalize the pressure, it rapidly rushes up the jet tube and enters the flask. Since HCl is acidic in nature, it converts blue litmus red. So we see a red fountain being formed. So from this experiment, we conclude that HCl gas is highly soluble in water. And this is one very important property of HCl gas.